Hello everyone, this is Ross Eldridge, and today I'll be talking about Project Part 6, which is the robust design of the system. So in the PRA of my system, I found that there were 6 main contributors to faults that would lead to site-wide power outages, and those would be the batteries on the UPS failing, the control module of the UPS failing, the generator not receiving the start run command from the PLC, the generator being under maintenance, a main breaker tripping on overload, and signal interference to or from the PLC. Now, of those 6, 2 of the faults are pretty difficult to mitigate anymore. The generator being in maintenance, it's something that's got to happen, so you can't really get rid of that. If you have a fault while the generator's in maintenance, you can't do much about it. And then the second one would be a breaker tripping on overload. That's what the breaker is designed to do. It's designed to clear faults and localize them such that you don't damage your equipment or your cabling going to the equipment. So those 2 faults you can't or shouldn't really mitigate anymore. But the other 4 faults you can mitigate with a more robust design. The first thing with battery failure, one of the things you can do is put more battery banks in parallel. That way you'll get the same voltage across each battery bank, but you can switch them on and off, or if one faults, you can go to another one. It also allows longer runtime. With all of them being the same voltage, with more battery banks, you've got more energy that can provide the same amount of voltage. So you can actually have longer run times with more battery banks. But there's drawbacks. Obviously, first is cost. More batteries is more cost. Second, this particular site is pretty small. So the need for more battery banks, it's just non-existent. All you really need to power are the PLC, and you can make an argument for the exhaust fans if you have a gas release at the same time that you have your utility fault. You want your fans to run. Third would be the physical footprint of the battery banks. Obviously, more batteries equals a larger footprint, and since this UPS sits inside a PDC building, which is another piece of equipment that needs to be purchased, with every increase in square footage required, that's increase in cost. So oftentimes clients will ask for, I need 5 minutes of run time, so you'll size your batteries such that you'll have 5 minutes of run time so that you can keep the amount of area you need as small as possible, so as to minimize that capital expenditure at the front end of the project. For the UPS control module, it's a little more difficult. You can't really change the control module. It's intrinsic to the UPS. I mean, obviously you can specify to the UPS manufacturer, you can say, hey, this is going to be for harsh environments, I need harsh environment duty equipment. But rather than doing that and spending crazy amounts of money for that type of robust equipment, what you can do, as I said before, is put this UPS in a PDC building. That way it's climate controlled, you've got HVAC, you've got pretty good dust sealing. Obviously you have doors to go in and out, but they're sealed so that when the doors are closed, you're not getting as much dust and other contaminants in the building. So that's the way you can mitigate that problem. As far as mitigating it any further, if it's necessary, a requirement by the client, you can obviously ask for harsh duty equipment, but it costs more. The third fault was the generator receiving the run start command from the PLC, and that's also tied together with the fourth fault being signal interference to and from the PLC. Ways you can mitigate this problem is use the correct cable for the type of signal you're transmitting. if you're transmitting an analog signal, you'll want to use a shielded cable. That way, any external electromagnetic interference is more or less absorbed by the shield and taken to ground at the PLC. It's actually, the shield isn't grounded at the instrument so that you don't provide a path for circulating current loops. If you've just got a digital signal such as a status or on or off, you don't have anything in between like an analog signal, you can just use a twisted pair. But you want to keep the twisted pair twisted so that if you do have any interference, it's going in one loop, but it's also going in the other loop, which is transposed, so they cancel out. Another thing you want to do is make sure that your terminations are clean and tight. You just want to make sure you have good electrical connections wherever electrical connections need to be made. And that kind of takes care of both of the generator run start command and the PLC receiving a bad signal. And with most of these issues, in order to make them more robust, you obviously have to spend more money. And that balance is sort of figured out between the design firm and the client, exactly how much money needs to be spent on making the design robust. That's it for today. Leave questions in the comments or on the discussion board.